Hello, you may call me the genicatist, and today I will be talking about the mechanism of Abilify, or aripiprazole as it is also called. I am a biology undergraduate, and currently I am taking pharmacology as a biology elective. I found this drug's mechanism of action absolutely fascinating, so I felt I had to share it with you all. Abilify is part of a class of drugs called antipsychotics. Antipsychotics are used to treat various psychotic disorders. There are two types, called typical and atypical. Typical mainly decrease a neurotransmitter called dopamine, which we will talk about later, while atypical decrease serotonin as well, in addition to the dopamine. Serotonin is responsible for regulating mood. Also, some examples of antipsychotics other than Abilify are Risperdal and haloperidol. What are psychotic disorders? These disorders are characterized by symptoms such as delusions or false beliefs, hallucinations, or believing that you see something that's not really there, disorganized thinking, facial expressions that look quite flat, and more. There are several different types, and the most commonly known one is schizophrenia. Some other examples are schizophreniform disorder, which is when someone has schizophrenic symptoms for less than 6 months, and there's schizoaffective, which is schizophrenia plus a mood disorder, such as bipolar. Scientists do not know what causes the underlying mechanisms for many psychotic disorders, but they do know what goes awry in the brain when someone has schizophrenia. It is associated with two things, both high and low levels of dopamine in separate parts of the brain. Throughout the brain run two paths that carry dopamine, called the mesocortical and the mesolimbic pathways. Dopamine is a neurotransmitter that is involved in helping reinforce pleasurable activities and motivating behavior. The mesocortical connects an area called the ventral tegmental area, or VTA, that takes part in the reward system of the brain, to the prefrontal cortex. The prefrontal cortex is responsible for abstract thinking, problem solving, and more. The mesolimbic pathway extends from the VTA to the ventral striatum. In schizophrenia, there's more dopamine than normal in the mesolimbic pathway, while in the mesocortical, there is less than normal. The mechanism of Abilify is unique and quite fascinating because it is what is known as a dopamine balancer. It can act as both a partial agonist and an antagonist for dopamine. Drugs have to bind to structures, called receptors, in order to have an effect. Antagonists and partial agonists have different effects upon the receptors. Antagonists block the receptors, which results in the molecule not being able to bind and no effect, while partial agonists have some of the same effect as the molecule is mimicking, but not the same amount. This relieves the symptoms of schizophrenia and other psychotic disorders by decreasing the amount of dopamine in the brain. Abilify also acts as an antagonist for serotonin, which would decrease the amount also. Scientists are mostly unsure about the underlying components of how Abilify can act as both a dopamine antagonist and partial agonist. However, they do have a theory. They believe that increased density of a type of dopamine receptor called D2L is responsible for this. That when it is high, that makes Abilify act as a partial agonist. They also think that another type of dopamine receptor called D2S is involved, and high levels of it also make Abilify act as a partial agonist. The opposite would be true for low levels of these receptors, with Abilify acting as an antagonist, with decreased densities of D2L and D2S receptors. In this video, we explore the fascinating mechanism behind Abilify. Abilify is an antipsychotic drug that is used to treat psychotic disorders and acts as an antagonist and a partial agonist for dopamine depending on the levels. It also reduces the amount of serotonin. We also went a bit deeper and discussed the theory that scientists have about how it can do this. We think it has to do with the receptor density of different dopamine receptors. Thank you for watching.